A particle moves along the x-axis and its coordinates vary with time according to the relation x is equal to t squared minus 2t, where x is measured in meters and t is in seconds. So this function x, which is in terms of t, is simply the displacement but as a function. Now we have that find the position of the particle at t is equal to 1 seconds and t is equal to 5 seconds. So we're going to evaluate the value of x at both t is equal to 1 and at 5 seconds. Then b, find the displacement at average velocity given the time interval of 1 to 5 seconds. And then c, you are simply taught to find the instantaneous velocity and instantaneous acceleration at t is equal to 3 seconds, while you are taught to use the method of calculus, which is differentiation. Okay, so let's get started. Let's look at A. So for A, we have two parts, and what we're going to do is we're going to write our function for x, which represents the position. This is t squared minus 2t. Now what we're told is, at first, for the first one, you evaluate the value of x, or which is the position, at t is equal to 1 second. So meaning that wherever there's t, we're going to replace with the 1. So let's do it at t is equal to 1 second. So we'll have x to be equal to, so t squared, which is 1 squared, minus 2 times 1. So this further simplifies to 1 squared, which is 1 minus 2. This gives us negative 1. Now we're told to say this value of x is measured in meters. So mean that here we have a negative 1 meter. So at t is equal to 1 second, we get negative 1 meter as the position. Now at t is equal to 5 seconds, let's see what we get. So here, while there's t in the function of x, we'll put a 5. So we have 5 squared minus 2 times 5. So 5 squared is nothing but 25. Then minus 2 times 5 is 10. 25 minus 10 is simply 15. And as usual, x is measured in meters. So this is our position. Now, the first one is the initial position for negative 1 meter, and this is the final position for 15 meters. So that is how you answer part A. We now move to part B, where we're taught to find the displacement. We're taught to say the displacement is simply the overall change in position. We're going to simply subtract the initial position from the final position, which is our change in x, which is overall change in position at the time intervals of 5 seconds as the final and 1 second as the initial. So when time is equal to 5 seconds, the position is 15 meters, and when the time is at 1 second, what you get for the position is negative 1. So now to find the change in terms of position, we'll say the final position minus the initial position. So this simply gives us 15, get 15 minus negative 1 for the initial. So this simply means we're going to get 15 plus 1, which is 16. So meters. So this is our displacement. We now move to the second part of part B. We're taught to find the average velocity. So average velocity in this case is just the overall position, change in position, divided by the change in time, where the change in position, which is the displacement, is 16. Then the change in time, we're going to say the final time minus the initial time. So that's the interval, which is simply 5 minus 1. So we get 16 over 4, and 4 into 16 goes 4 times, and the units for this quantity is meters per second. Okay, so that's how you answer part B of this question. From there, we then move to C. Now C, what we have is we're taught to find the instantaneous velocity and instantaneous acceleration. So instantaneous velocity. Let's find the instantaneous velocity. So instantaneous velocity is you're looking at the rate of change of the displacement, but in this case it is in terms of the function. So you simply differentiate x with respect to time. So you differentiate the displacement with respect to the variable that it does, which is time. And after you find this has to be evaluated at t is equals to 3 seconds. So let us write our function of x. Our function of x is equal to t squared minus 2t. Now let us differentiate this. So to do this, we're going to undergo a process of differentiation. So we're going to undergo a process of differentiation to simply find the velocity from the displacement. Under the process of differentiating, we're particularly using the power rule method to simply undergo this process. Now this is why you drop the power to multiply with the 2, so it will be 2t. Then the same power you subtract the 1. Then say minus. Second part, the power is 1, so it will multiply with the 2 this side. So it will be 1 times 2. Then the same 2, which is the power 1, always subtract a 1. That is according to the power rule. Now, this gives us v to be equals to 2t. 2 minus 1 is just 1, so minus. So this would be 2, then times t to the power 0. So this just gives us our v to be equals to 2t minus 2. Because t to the power 0 is just 1. Now, we're taught to find this velocity at t equal to 3 seconds. So what we've obtained, why they still put a 3. So this will give us our v to be equal to 2 multiplied by 3, which minus 2. So we get a 6 upon multiplying, then minus 2. Then we get a 4 meters per second as the instantaneous velocity. Okay, like that. Now, to find the next part of the problem, which is the instantaneous acceleration, what you just have to do is to simply differentiate a function. Now, this function of differentiating is simply velocity, that is with respect to time. So differentiating v with respect to time. So our function v is the one that we just obtained in the previous problem, which is 2t minus 2. So our v is equals to 2t minus 2. Okay, then like what we did to find acceleration, the one which is the power for t will come and multiply with the 2. So you say you have 1 times 2, then t, the power which is a 1, you subtract the 1, then minus, there you have, it's the same as t to the power 0, which will multiply with it, which would be 1 to multiply with the 2. So this power 0 come and multiply with the 2, then you have the same t to the power 0 minus 1. So now you have acceleration because 1 times 2 is 2, then t to the power 1 minus 1 is 0, then minus this one being multiplied to 0 is just 0. So our a is equals to 2 times 2 to the power 0 just gives us a 2. Now here we can't substitute t is equals to 3 because there's no t in our final expression.